So in this activity, we're going to be taking the motion graph that we made based on the motion that we want for our automata, and then we're going to put that information into a polar grid paper. What this polar grid paper shows us is the angle of rotation and then the distances. So we're just going to go ahead and map these, and I'll kind of explain it as we go along. So if you look at the polar grid paper, we have 45-degree increment lines along the side. So it starts at 0, 45, 90, so forth and so on. Just like the vertical displacement measurements that we took with the angle of rotation. So we're going to take this 1.25 at 0 degrees of angle of rotation and actually draw a dot on our polar grid paper. So this is our 1-inch mark. This is our 2-inch mark. Each of the little less dark lines are eighths of an inches. So we know that 1.25 is 1 1/4 inches or 1 2/8. So we're just going to put a little mark here at the 1 2/8 inch mark. And then I'm just going to go ahead and keep going around and doing the same thing. So at 45 degrees, so that would be this line right here, we are at 1.325. So that is at 1, 2, and a skosh. So this is a little subjective, so just put your line in there. Then at 90 degrees, we're at 1.6. So I went ahead and went around to each angle of rotation and put on its mark. So at 135 degrees, I put in the mark. At 180 degrees, I put in the mark, so forth and so on, all the way around my polar grid paper. Now, here's where we're going to take our polar grid paper and translate visually our line graph into something that makes sense for us. We're going to play connect the dots. So I'm going to start at 0 degrees, and I'm just going to try to connect these lines as best I can. I know it's kind of freehand, so it's not going to be perfect, but you get the basic idea. And there is the approximate shape of our cam. Obviously, it's going to be a little bit smoother if I wasn't drawing on a computer. That gives you the rough idea of what your cam shape is going to be. And then obviously, you imagine that there's an axle hole right here. So what kind of cam would we call this? Yep, we would call this an eccentric cam. Now what we could do is do a prototype. We could cut this out, put it on some cardboard, make up a little physical assembly to see if we actually get the motion that we want. That's something that we might actually do in class. Otherwise, we're just going to jump right over to Inventor and have Inventor model this same cam for us. So I'm just going to pop over here into Inventor. We're going to start up a new part. I'm going to put it on my YZ plane, because I know that's how I've oriented all the other parts in my Inventor. Just makes things a little easier right from the get-go. Now, I am going to be using a lot of points and construction lines to get this all started. This is going to be a little ugly to begin with, and then it'll start making more sense. So remember, this is our origin point. We always want to start everything off of our origin point. And again, we are just going to be using this information, our angle of rotation and our vertical displacement, to plot lines, to plot points, just like we did on the polar grid paper in Inventor, and then we'll connect the dots. So let's start by using some points, and make sure that you have center point shown up. It just pops out a little bit easier, so I like that. We're going to start out really, really basically. We're just going to put a couple of points. So I know that I'm going to have, just like from my polar grid paper, I'm going to basically recreate this. So I need my X and Y planes. I'm going to need some angles off at 45, 135, 225, and 315. This is actually easier than it thinks. So what we're going to first do is just kind of roughly draw in. Let's change a color here. We're going to roughly draw in a point here and here and here, all the way around our point of origin on Inventor, and then we're going to dimension those in. All right, so here we go. So let's just put a point right there. And you can see I'm not being very particular about their placement because I'm going to dimension them all in. Now let's just start at the 0 degree angle of rotation. So I chose my dimension tool from my point of origin. I'm going to click up to that point, and then I'm going to put my dimension in. Now my dimension is right here, my vertical displacement of 1.25. 1.25. Put it in. The next one is going to be on a bit of an angle. So this is how you do it. Again, make sure your dimension tool is on. You click the point of origin. You're going to click the point. And when you start to drag kind of at an angle, you'll notice that the little symbol next to my mouse point changes from an up and down to a angled dimension. So once I click that, you can see it's actually realizing that I want to measure on that angle and allowing me to put in this case, our vertical displacement of 1.35. I'm sorry, 1.325. All right. Do our next one, which is at 90 degrees, and that is at 1.6. And again, we're going to do another angle one. So I'm going to click on the point of origin. I'm going to click on my point. Right before I click on my point, you can see how the arrow symbol next to my mouse pointer is going horizontally. As soon as I start to drag on that angle, it changes to an angle dimension. And that is my 135 degree, so 1.215. Whoops, I'm sorry, 2.215. And then I'm just going to keep going around. And the sketch is going to get a little bit busy. With all of these dimensions. There is more than one way to do this, but this is the way I've chosen to teach it to you this year. So again, at an angle, drag in, and that would be a 1.325. Okay, whoops. 1.325. Now that I have my vertical displacement dimension set, I need to set my angles. And I only need to do a couple of these because obviously the 0, 90, 180, and 220 or 215 or 225 are already set. And I only need to establish one angle here. And then this is how we're going to do this. So here, what we're going to be doing is using our horizontal line as our point of reference. So we're going to start out with our horizontal line point. You're going to click on what's called the vertex or the origin point, and then you're going to click on the point that you're trying to create the angle between. Right, so we're going to get this lovely angle constraint, or excuse me, angle dimension that's going to allow us to set that dimension of a 45-degree angle. So put in your 45, and you're going to notice that this line here is going to move ever so slightly, and now we have a 45-degree angle set there. If this is 45 degrees, we know this is 45 degrees, so we don't need to set that one. So we just need to do another one here, and another one here, and another one there. So again, I'm going to start out with my stationary point. So I'm going to start here. I'm going to go to the point of origin, and then I'm going to go down to the point that I'm trying to set the angle for. Set in my 45, and it has moved. And we'll repeat that over here. And one last time to the vertex, to the angle point I want to set. We're almost there. And there we go. Now, all of our dimensioning is done. Save and save often, guys. Right, now we're on to the fun stuff. We're going to be using a new tool. It's under line. It's called Spline Interpolation. So just go ahead and click that. And now we are connecting the dots. Start at 0, just because. Make sure that you're actually getting on that point. So you should get the little green dot. Click on it. Click on the next point. Click on the next point. Don't worry about what the line is doing. When I go like this, it doesn't matter. Just click on your points. Make sure you're connecting all of those dots. And you'll notice as you connect all those dots, Inventor is doing a bunch of math for you. Right click and OK. And it has connected all your dots for you, and it has created your cam. So we can finish the sketch. Zoom out a little bit. We can extrude this, say to 3/16, and we have a cam. Only thing we need to do now, we need to put in our axle hole, which I should have done before I left my sketch. right in the center. And I'm just going to redo my extrusion. And voila, we have a lovely little eccentric cam. You can do this for any cam shape. It's pretty straightforward. Draw your motion graph, plot it out on the polar grid paper, and then translate it into Inventor. So that's how you can use polar grid paper and a motion graph to ultimately make yourself a cam.